The appearance of our sun is quite different from what you may have imagined. Contrary to popular belief, it is not a bright yellow ball of fire. Rather, it has a greenish hue. Scientists determine a star's temperature by analyzing the color spectrum it emits. Each color corresponds to a specific wavelength, which astronomers use to gauge the star's heat. Cooler stars appear red, while the hottest ones appear blue. Our sun primarily emits energy at a wavelength close to green. However, due to the presence of other wavelengths, these colors blend together, and our eyes perceive them as a vibrant white. When viewed from the International Space Station, the sun appears yellow, as our atmosphere effectively scatters blue light. Consequently, without the blue wavelength, the remaining colors combine to form yellow. If our sun were truly yellow, its temperature would be approximately 800 degrees Celsius lower. This would cause the habitable zone in our solar system to shrink, resulting in Earth becoming a frozen, lifeless rock. But that's not the only misconception to address. Although the sun is indeed hot, it is not on fire. Burning is a chemical reaction that occurs when oxygen reacts with fuel. However, our sun operates in a different way compared to burning. Like the majority of stars in the universe, the sun is essentially a massive ball of gas, primarily composed of hydrogen and helium. Unlike burning, which requires oxygen, the sun's energy generation process relies on nuclear fusion. Deep within its core, hydrogen atoms fuse together to form helium through a process called nuclear fusion. This fusion process releases an immense amount of energy in the form of light and heat, which is why the sun is incredibly hot. Moving on to explosions in space, they are not possible due to the absence of air. In the vacuum of space, there is no atmosphere and hence no oxygen. Without oxygen, fire cannot occur. While the night sky may appear to be filled with an overwhelming number of stars, it is indeed possible to count them. Thanks to the diligent work of scientists at Harvard, we have the Yale Bright Star Catalog, which provides information about the stars visible to the naked eye from Earth. According to this catalog, there are approximately 9,110 stars that can be observed without the aid of telescopes or other devices. So while it may seem like an impossible task, you can embark on the challenge of counting these stars for yourself. In movies, navigating through the asteroid belt is often portrayed as a perilous endeavor, requiring exceptional piloting skills. However, the reality is quite different. The asteroid belt is not a dense and treacherous obstacle course of death as often depicted. It is indeed home to trillions of space rocks, varying in size from minuscule space dust to objects about a quarter the size of the moon. While it is true that there are around 100,000 asteroids over 1 kilometer wide, they are widely dispersed throughout the vast expanse of the asteroid belt. Spanning a distance of 225 million kilometers between Mars and Jupiter, the belt is approximately 1.5 times the distance from Earth to the Sun. As a result, the space rocks are spread millions of kilometers apart, making it highly improbable for a spacecraft to collide with one. Contrary to popular belief, if you were to be ejected from an airlock into the vastness of space, you wouldn't instantaneously turn into a frozen popsicle. Freezing in space requires heat transfer from the surrounding environment to your body, but in the vacuum of space, heat or cold doesn't propagate quickly. While your body would eventually freeze, it would take hours for this to occur. However, it's important to note that in such a scenario, you would likely have succumbed to other factors long before freezing to death. Additionally, the notion of exploding in space is another misconception. In reality, you wouldn't explode unless you were to inflate. If nitrogen were to accumulate in your bloodstream, it could form bubbles and cause your body to swell up to twice its normal size. This inflation can lead to severe consequences, but it's important to clarify that simply being in space does not cause spontaneous explosions. However, the true danger in space lies in the lack of oxygen. Contrary to other misconceptions, it is the absence of breathable air that poses the greatest threat. In fact, after just 15 seconds in space, your brain would begin to suffer from insufficient oxygen supply through your bloodstream, leading to loss of consciousness. Within a mere 2 minutes, your other vital organs would start shutting down one by one, resulting in an irreversible outcome. Game over. While space may give the impression of being incredibly cold, the reality is slightly different. Space itself does not possess a defined temperature. Temperature is determined by the movement and energy of particles. In the true vacuum of space, where there are no particles to move around, the concept of temperature becomes irrelevant. This is why the vacuum of space is considered temperature featureless. However, it's important to note that outer space is not a perfect vacuum. there are still particles and radiation present which can generate heat. Certain regions of space, particularly those surrounding stars, can be quite hot. Nevertheless, as one moves further away from stars, the particles become more dispersed, resulting in colder areas of space. Some dense gas clouds, for example, can reach temperatures as low as -263 degrees Celsius. Interestingly, while Mercury is the closest planet to the Sun, it is not the hottest. However, it is an extreme planet in terms of temperature fluctuations. During the day, the surface temperature can soar to a scorching 430 degrees Celsius, while at night it plummets to a bone-chilling -180 degrees Celsius. However, the most inhospitable planet in our solar system is Venus. While Mercury lacks an atmosphere to retain heat from the Sun, Venus possesses a thick and dense atmosphere that creates a greenhouse effect. This effect amplifies the heat, leading to extreme temperatures on the surface of Venus. In fact, it is like experiencing global warming on a highly intensified scale. The surface of Venus can reach scorching temperatures of approximately 475 degrees Celsius, making it a true hot hell in our solar system. It's important to note that our solar system is not stationary within our galaxy. In fact, it is hurtling through space at an astonishing speed of 220 kilometers per second. This speed is 7 times faster than the rate at which Earth revolves around the Sun. It takes our solar system approximately 230 million years to complete one orbit around the Milky Way. To put this into perspective, the last time our solar system occupied its current position, Earth was home to a single supercontinent, and dinosaurs were just emerging. Contrary to a common misconception, planets do not simply orbit around the Sun in isolation. The objects within our solar system maintain a delicate balance. Despite the Sun's massive size and gravitational pull, other planets actively participate in a gravitational tug-of-war. Instead of solely orbiting the Sun, planets and moons revolve around a central point located between them and our star. This dynamic interplay of gravitational forces shapes the intricate dance of celestial bodies within our solar system. The point at which celestial bodies orbit each other is known as the barycenter. In the case of Earth, the barycenter is so close to the core of the Sun that the difference is negligible. However, for Jupiter, this point is located approximately 55,000 kilometers away from the center of the Sun. As a result, the gas giant and the Sun orbit around this common barycenter, showcasing the intricate dance of gravitational forces between them. In the vastness of space, sound does not propagate as it does on Earth. The absence of a medium for sound to travel through, coupled with the vast distances between molecules, causes sound to fade away quickly before it can travel a significant distance. This is why the famous phrase, "In space, no one can hear you scream," holds some truth. Cosmic catastrophes such as supernovas and colliding black holes occur in silence, as the sound they generate dissipates within the void of space. However, certain regions in space, like the hot gas cloud surrounding the black hole at the center of the Perseus galaxy cluster, contain enough particles for sound to travel through, creating unique acoustic environments. Thank you for watching, and if you liked the video, make sure to like and subscribe. Until our next cosmic adventure, stay curious and keep reaching for the stars.